Hello. Now today we are going to discuss the same circuit that we discussed in the previous video. So here only thing is that our input is changed. Here instead of using step input, we are using a pulse input whose value changes from 0 to 5 volt. Here the input waveform has a 50% duty cycle, so for t by 2 amount of time it's high and t by 2 amount of time it is low for one cycle. And here one condition is given, like the time period of this pulse is very greater than RC. So in the other way we can say that the time period is sufficient such that this RC circuit or this capacitor can charge or discharge. So now how to analyze this kind of circuit with this pulse input? Now let's first analyze for 0 to when t is equal to 0 to t by 2. In this time interval, what will happen at t is equal to 0 minus capacitor voltage is 0 volt. So let us consider the initially the capacitor does not have any charge, so initially the capacitor has 0 volt, but at t is equal to 0 plus also the voltage of the capacitor is 0 volt, because the capacitor can hold its value if impulse of current does not flow through it. Okay, so at t is equal to 0 plus the voltage of the capacitor is 0 volt. Now as here given t is very greater than RC, so the capacitor get proper amount of time to get fully charged. Okay, so within this t by 2 interval the capacitor is fully charged, and the final value of the capacitor, like VC at infinite, or VC at t by 2, it will become 5 volt. So this condition justifies that the capacitor have sufficient amount of time to charge to 5 volt, because its time constant is very small with respect to the time period of this input pulse. So for 0 to t by 2 the output actually look like this. The capacitor charges, so suppose here is input 0 to t by 2 and this is my output. Okay, so capacitor is fully charged, so the capacitor reached to 5 volt within t by 2 time. Now at t by 2 what happened? At t by 2 plus the voltage, the input voltage becomes 0. So now in this interval t by 2 to t, our circuit will look like this. Input becomes 0, so we can draw the circuit like this. This is R, this is C, and here the voltage of the capacitor is 5 volt initially. Now what happened in this period t by 2 to t, the capacitor will discharge through this resistor, and as t is very greater than RC, so the capacitor gets sufficient amount of time to fully discharge. So our output will something look like this for one cycle, and for the next cycle this waveform will repeat. Okay, so now if this is the input, then our output will simply look like this. Okay, so this is our output waveform. Now here given T is very greater than RC, so we can write 1 by F very greater than RC. So F is very less than 1 by RC. Okay, so here F is less than very less than 1 by RC. And can you say like what kind of a filter this is? So this is a passive filter. So can you guess like what kind of filter is it? Low pass filter or a high pass filter? So how you can check? Now for omega tends to 0, what will happen? The capacitive reactance become how much? It will tends to infinite. So what you give in the input will get at the output. Okay, so what you will give the input, you will get the output. But if omega tends to infinite, then a capacitor is short circuit. So whatever may be the input, your output will tend to 0. So with respect to frequency, it will look something like this. So after a certain frequency, it will decrease. This is our 3 dB cutoff frequency. So this is basically the structure of a low pass filter. And what this condition actually saying, this like the pole frequency 1 by RC is much greater than with respect to F. So the filter will pass almost all frequency except the highest frequency, like, so all the low frequency component will be passed through the circuit, and here the high frequency component is actually placed here. Okay, so you can see that the high frequency component can go to the output, only the low frequency component and the other frequency component can pass through the circuit. So that's why the output will look like this. So without the extremely high frequency component, our circuit pass all the frequency, so that's why the waveform look like this. Okay, so this is how you can analyze this circuit. So for the pulse input, your output will look like this. And you can do another thing, like suppose this type of input is given, like you have to tell me that what will be the output if this kind of input is given, and the condition is T is much greater than RC. So this is your home task. So please let me know the answer in the comment, like what will be the shape of the output waveform, and what will be the peak to peak value of the output. So please let me know in the comment section, and thank you for watching.